Here are the items that are going to be included in the shipment. This is a standard controller. This is good up to 1.5 amps. It includes a connector that has screw terminals and also has remote control, 0 to 10 volt for speed control, and then dry contact for changing state of direction and stop and go. The other unit here is a higher powered unit. This is good for motors up to 3 amp rating, and you can see this one has got a blue bottom on it. Also, the current adjustment is on the side. In the lower current unit, the adjustment is in the back, and you'll have to do that with a Phillips screwdriver. I'll have it preset so it runs nicely with a NEMA 17 motor at about 600 milliamps. So other things will be included be 2 power supplies. You'll need to supply the particular cord that you need, with a couple of small screwdrivers, a Phillips and a slot screw. And here's the cable connector I made so that if you have some bare leads to deal with, you can just open up these and stick the stripped wire in there and clip it down. They'll just make it a little bit easier to get it hooked up quickly. And then finally, a benchtop power supply, which we'll talk about later, that you can use to determine how much power is being drawn from the unit. So for right now, let's just go ahead and make one of these run. We'll grab one of these power supplies and plug it in like so. And before I plug in the mains power, I want to make sure that we get the motor hooked up first. So I've already got this one set up here. Actually, the wire scheme for this 114 stepper pump is black, green, blue, and red right across that way. And notice the screws go down, and I'll pull that connector out. We don't need that right now. And plug it in there, and we'll give it some power. And you'll see it started up, 0 RPM, it's off, direction, and then here's the current that is set. Again, you set the maximum current in the back. General rule on setting the current is that you would start off at a value that's about half of what the motor rating is. This one is rated at 1.2 amps, so I've got the setting here for something a little bit above 600 milliamps. So let's just turn this on so you can see it run. So let's put a tube in there now. This is a 4.8 by 1.6 millimeter wall Marprine tubing. Change directions, and I will put a little back pressure on it. So, okay. Now let's take a look at the power on this. So what I'm going to do is, while the motor is off, I'm going to disconnect the this power supply here and get it out of the way. And I will connect this power supply over here. I've got an adapter here that will be included, and it's hooked up to the alligator leads there. So turn this on, and I already have it set at 24 volts. The amperage, I've got it turned all the way up so that we're not looking to limit the current on this. So anyway, let's just go ahead and turn this on and watch the current draw here. Note the current draw is not going to match up with what's here in the iMax setting, because the controller sends out a voltage that's lower than 24 volts, so the current is that comes out of here is going to be different. So anyway, let's get it going. So you can see we're running about 200 milliamps there. Let's try pinching this off here. A little back pressure. Increases it a little bit. Let's take it on up to higher speed. Let's take it on up to 400 RPM. And now we'll try cutting off, putting some back pressure. You can see we push it on up to 300 milliamps or so. Change directions. And then we'll stop it. Okay, so the next thing we're going to do is to take a look at driving this thing with a 0 to 10 volt remote. So to do that, I've got a signal generator. This one's set up to do 0 to 10 volts, so we'll go ahead and hook it up right now. Turn off the power, the motor, and everything. Push that. And here I'm going to use the Y adapter. And push some of this stuff out of the way, so give us a little more room. Okay, so with this Y adapter, I'm going to plug one end of it into the current generator, or the signal generator, I mean. And then I've got two wires here that are for 0 to 10 volts, are right here. So we'll need to connect those. 0 volts goes right here. And the 0 to 10 volts over in this other spot. By the way, this device is Drock signal generator. I got it off of Amazon. Currently they're not available, and recently I bought one and it was not, actually didn't work correctly. But this one seems to be okay. So let's give it a try. All right, I'm going to turn the power back on, and there we go. So the way this works is that these controls are still in effect over here, but as soon as you turn it on, as soon as you get above 0.5 volts over here, this thing will start generating the speed. So as you can see here, as we get to let's see, a little over 1 volt, it's at 25 RPM, and the pump is running. So if we take it down to 0, okay, now I can go over here and set this at 140 RPM, but as soon as I get above a certain threshold, well, actually the voltage or the motor stops, or the controller stops sending signals as soon as I get above, I think it's 0.2 volts, but at 0.5 volts we start generating some RPMs over here. Okay, in addition to that, we also have, I've taken out the stop, start, and direction controls. These are just momentary contact. This is the start, stop. You can tell by the red, it matches that. You touch it to ground, and it changes the state. Touch it again, it starts up. Same way with the direction. You touch it, and it changes direction. So it latches, so if you're doing this from a PLC, you'll have to pulse it to change state and then pulse it again. You can't just make it high or low, and you'll actually have to pulse to change directions and the stop start. And that's it for now. The only other thing is that the higher current unit will push motors up to 3 amps. This might be good for the 313 pump with a stepper motor, etc. And the controls are the same. The remote controls are the same. The only difference here is that the changing the current is on the side. On this other one, you have to get to it from the back.